Good morning, Algebra 2 concept students. Today, we are going to expand on our idea of solving inequalities, and we will be remembering all of the concepts that we've talked about with inequalities, as far as if you multiply or divide by a negative number, reverse the sign, and you have many solutions, and so on. Today, we're going to talk about compound inequalities and potentially get to some absolute value inequalities. But first of all, a compound inequality is defined as two inequalities joined by the word and or by the word or. So examples of this. First example here is saying that x is greater than negative 4 and x is, I apologize for this, this should say less than 3. And the reason will be very obvious here in a little bit. Because if the word is and, both of these need to be true. We are looking for a number that is greater than negative 4 and is less than 3. If I show this on the number line, I've got negative 4 here. This would be an open dot because it's not equal to. Positive 3 is right here. This would be an open dot. And I need to be greater than negative 4, but also less than 3. So basically it means I'm talking about everything between a negative 4 and a positive 3. All right, now, since it's this way and it's a tween, and I'm going to refer to this as what we call a tweener, I could write this like this. The x is between negative 4 and 3, and I would need less than signs here because x is greater than negative 4 and less than 3. And you can only write something like this if it's a tweener and if it's an and statement. So similar to this, if I had something like negative 2 is less than x is less than 1, this would mean that I'm talking about everything between negative 2 and a positive 1, and these would be open dots. If I would have equal signs in here, then we just have closed dots, but it's still between them and it's still a tweener. So an and statement, we're going to have a tweener and we're going to write it like this. All right, if we have an or statement, x is less than or equal to negative 3 or x is greater than 1. Now the key word is or here because there isn't any numbers that would be both of these. You can't be less than or equal to negative 3 and also greater than 1. So we've got at negative 3, we're going to have a closed dot. And everything less than that. And at a positive 1, we're going to have an open dot, and everything greater than that. So you can see, in this case, we're talking about what I'm going to refer to as a splitter. It's an or statement, and all or statements are going to be basically splitters when they're graphed. So another example of this might be like x is less than 5 or x is greater than 7. This would be shown as less than 5, greater than 7. You can see it is a splitter. All right, so examples here when we're solving these compound inequalities. So these three, this is numbers 1, 3, and 5 on page 37. These are what we refer to as tweeners. And we've got 3 parts to this. So I'm going to work on this inside right here and try to get this x by itself. So like we've been doing, I'm going to undo that. I'm going to subtract 2. But I'm going to do this from all 3 parts now. So now I've got negative 12 is less than 3x is less than or equal to a positive 12. And then I would divide everything by 3. and I would have negative 4 is less than x is less than or equal to a positive 4. This is a tweener, so I'm going to have an open dot at negative 4. I'm going to have a closed dot at positive 4, and everything in between. This next example, again, I'm trying to get this x by itself here. So I'm going to add 10 to both or all three parts. So I have 28 is less than 4x is less than 60. I would then divide everything by 4. I've got 7 is less than x is less than 15. And I have solved that. This is a tweener again. I'd have an open dot at 7. I'd have an open dot at 15, and everything in between there. Next example here, number 5. I'm going to add 2 to all three parts of this. So I've got 24 is less than 6w is less than 84. I can divide everything by 6. 4 is less than w is less than, that goes in there how many times? 14 times. So I'm talking about everything between 4 and 14. It's a tweener, and it's open circles. And then dealing with the ors. So these are problems like 2, 4, and 8. Remember, if we have an or statement, we're probably thinking it's a splitter. Here we just do both sides. We do 2 inequalities, so I have 3a is less than 23 minus 8 is 15. Divide by 3 and I get a to be less than 5. Over here I'm going to add 6. I want to get rid of that 1/4, so I'm going to multiply by 4. Those cancel, so I get a to be greater than 52. This is an or statement, which should be a splitter. And I am less than 5, and I am greater than 52. So as I expected, it is a splitter. Number 4, same type of thing. I'm going to subtract 2 here. So I'm just solving this just like we did before. I'm going to divide by 5. And I'm going to get k to be less than negative 3. On the right side, I'm going to add 1. I'm going to divide by 8. I'm going to get k to be greater than, let's just reduce this. 4 goes into each of those, 5 halves. It's an or statement. I'm going to be less than negative 3. And I'm going to be greater than 5 halves. And number 8, again, it's an or statement. Do each of these individually. I'm going to have 4d is greater than a negative 8. I'm going to divide by 4 and get d to be greater than negative 2. Over here, I'm going to subtract 5. I'm going to get divide by 2 and get d to be less than 3. It's an or statement. So now if we're looking at this, we need to be greater than negative 2. That would go this direction. D is less than 3. That would go this direction. So we should be alert here. This is kind of a weird situation. This number's got to be greater than negative 2 or has to be less than 3. And I believe that is true for every single number. Any number you say is either less than 3 or greater than negative 2. So we would say this one, the solution would be all real numbers. Everything makes this true. All right, so this is on compound inequalities. You should be able to work on the practice now in 1.6 and do those first few that are dealing with compound inequalities.